Hey everybody. I think it would be nifty cool if we practiced graphing sine and cosine a little more. Um, I encourage Mr. Paws to put you into breakout rooms, if time permits, to work on some of these with a partner. Um, I think he should give you a pop quiz. I think maybe this would be a great time for a CFA, or tomorrow. Tomorrow could be a great time for a CFA, even just one problem now. Come on, Mr. Boss, give them a quiz. Yeah. So how about this one? Y equals 5 cosine 3x plus pi over 6 minus 1. Will you show me how to graph that? Yeah, I do want to start with setting that argument 3x plus pi over 6 equal to 0, and 3x plus pi over 6 equals 2 pi. Remember, this is for one period. If I need two periods, I'm going to have this, I'm going to have this, and I'm going to have the third one, 4 pi. Okay? All right, but I'm only asking for one period. 3x equals negative pi over 6, x equals negative pi over 18. And here, this is 12 pi over 6 minus 1 pi over 6, 11 pi over 6. And so x equals 11 pi over 18. So our graph starts here, our graph ends here. Negative pi over 18, 11 pi over 18. If I'm finding halfway in between those, I add the numerator, minus 1 plus 11 is 10, and double the denominator. So that's going to be 10 pi over 36. And I really would like these to all have a common denominator. So I'm going to reduce this to 5 pi over 18. From negative 1 to 5 is 6 pi over 18. And from 5 to 11 is 6 pi over 18. So I have the same distance on each side. I feel very confident about this middle being 5 pi over 18. But I need quarter points, and so I need to average these. I'll add the numerator and double the denominator. 4 pi over 36, or 2 pi over 18. And now I see this goes up by 3, and up by 3, and up by 3. You get 8 pi over 18. Okay, so those are my points, and now it's time to draw in the shape. The shape for cosine, ooh, it's a positive cosine. Positive cosine starts high, goes to the midline, down low, and then back up again. Do not make an absolute value shape. Do not make a parabola shape. This is not parabola. This is concave down, concave up, concave down. Okay? Great. Sinusoidal axis, y equals negative 1. And then finally, use that amplitude to figure out if I was at negative 1 and added 5, I would now be at positive 4. And here, if I'm at negative 1 and I add 5, I'm going to be at 4, just like I am over here. This middle point at 5 pi over 18, I was at negative 1, and then I went down 5. Minus 1 minus 5 is minus 6. And there's my graph. Okay? You are welcome to put in your axes if you want. They would look like this. I don't want to do that. Yeah, I mean you can, but no, because then you're going to like be all confused with these things. Don't do it. Just don't do it. Okay, let's warm up with a couple more. How about y equals negative 1/2 sine pi over 6x minus pi over 4 plus 5/2. Please graph that one. Pause the video, give it a try. Excellent. So, did you start with pi over 6x minus pi over 4 equals 0, and pi over 6x minus pi over 4 equals 2 pi? I hope so. So I'm going to add pi over 4. And no, I don't want to divide by pi over 6. Look, that's not a good time for anyone. Multiply by the reciprocal. Tink, 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 and even some reducing. And so I get x equals 3/2. Over here, 8 pi over 4 plus 1 pi over 4 equals 9 pi over 4. And again, I'm going to multiply by the reciprocal. I mean, you're welcome to divide and have a complex fraction. I'm just telling you what I do because I'm lazy. The pi's cancel. I can take a 2 out of there, and I get 27 over 2. So I'm starting at 3 over 2, and I'm ending at 27 over 2. Okay. 3 over 2, 27 over 2. Halfway, I'll add the numerator, 30, and double the denominator, 4. 30 over 4, because I want this denominator of 2, I could reduce that to 15 over 2. From here to here is 12/2. From here to here is also 12/2. Good. But I need quarter points. So I'm going to add these and get 18 pi over 4, or 9, I'm sorry, no pi. It's just 18 over 4, which reduces to 9 over 2. From 3 to 9 is 6. From 9 to 15 is 6. Oh, this will be 21 over 2. Well, let's confirm it. 42 over 4 does reduce to 21 over 2. Good. So now we've got this, and it's time for us to draw in our shape. So, do you draw in this shape? No. Why not? I thought sine started on the midline, went high, back to the midline, down low, and back to the midline. Yes, that's true. Positive sine does do that, but this is negative sine. So negative sine starts on the midline and goes low, back to the midline, then high, and back to the midline. So here's our graph. And we're going to label y equals 5/2 as our sinusoidal axis. And we're going to go down 1/2. 5/2 minus 1/2 is 4/2. And here, we're going to go up 1/2. 5/2 plus 1/2 is 6/2. So 21 over 2, 6/2. You can certainly simplify this to 2 and simplify this to 3. I don't care. Really. It's fine by me. What does Mr. Paz say? This negative gives us the shape. Just let the negative inform the shape. Here, I'm going from the midline up that amount. Here, I'm going from the midline down that amount. The amplitude is that number, not this. This tells me the shape. Okay? All right. One more? 2 more? What do you think? How about this one? Y equals 1/3 sine 3x minus pi over 6 minus 5/3. Graph one period of that, please. Hey, welcome back. Did you set the argument equal to 0 and 2 pi? This is 12 pi over 6 plus 1 pi over 6 is 13 pi over 6. And so x equals 13 pi over 18. Right. So pi over 18 is where we start. 13 pi over 18 is where we stop. pi over 18, 13 pi over 18. Halfway in between, 14 over 36 is 7 pi over 18. Add the numerator, 8 pi, double the denominator, 36, 8 pi over 36. That'll work. Or, if you want to keep the common denominators going, reduce. You can still reduce more, but then you'll lose the common denominators. Here we're going to have 20 pi over 36. Or, if we simplify a little, 10 pi over 18. This is a positive sign, so draw in the positive sign shape. Concave down, concave up. Here's y equals negative 5/3. We're going to go up 1/3. Minus 5 plus 1 is negative 4/3. The x value is 4 pi over 18. Here, the x value is 10 pi over 18. And the y value here, minus 5/3 minus 1/3, is minus 6/3. Okie doke. That's our graph. That's all it is. See, it's getting a little faster, isn't it? Like you're getting a little more comfortable with the process. How about this one? Y equals negative 4 cosine 2 pi x minus pi over 3 plus 7. Okay, so we start off with 2 pi x minus pi over 3 equals 0, and 2 pi x minus pi over 3 equals 2 pi. This is for one period. One period starts here and ends here. If I needed a second period, 2 pi x minus pi over 3 equals, that's right, 4 pi. This is where the second period would start. This is where the second period would end. But I'm only asking for one period today. 2 pi x equals pi over 3. And so x equals 1/6. Why 1/6? Well, I'm going to divide by 2 pi. Tink, tink. 1 over 3 times 2 is 1/6. Here, I'm going to add pi over 3 to 6 pi over 3. So 1 pi over 3 plus 6 pi over 3 is 7 pi over 3. And I'm going to divide by 2 pi. So I'm getting 6 again, and the pi's cancel, and so x equals 7/6. That period starts at 1/6, ends at 7/6. Okay. 1/6, 7/6. Halfway in between, 1 plus 7 is 8 over 12, which can be reduced to 4 over 6. Going up by 3, going up by 3, that gets a smiley face. Don't forget, though, to find the quarter points. Add, double. Add, double. Now, if you really want, you could change these 6ths into 12ths, but I don't recommend it. So now we're supposed to draw in the shape. What shape do we draw in? Does it start here? Does it start here? Does it start here? Negative cosine starts low, goes to the midline, then up high, and back down again. Concave up, concave down, concave up. Please make sure we have that concavity in this graph. Okay, so y equals 7, our sinusoidal axis, and I'm going to go down 4. 7 minus 4 is 3, and here I'm at 7 plus 4. 4, 6, 7 plus 4 is 11. And that's that point there. And here, 7, 6, 3, because the y value here and the y value here should be the same. Okay. Well, now I think that it would be wonderful if you were in class and had a quiz on this right now. because I think we've done some nice practicing here. I hope you're a little less scared of this. Don't worry, we'll practice it a little more in our third video on sines and cosines. And then after that one, we'll start dealing with tangent, cotangent, secant, cosecant. But you got to be really comfortable with sine and cosine before we go anywhere near secant and cosecant. Okay, so let's go backward. And going backward, remember from last semester, meant that I gave you a graph. And so our graph as 0, 3, pi over 2, negative 3, and pi 3. Okay, and I'd like you to write the equation for this. So, first of all, I'm going to say in today's video, a sine bx or a cosine bx. Only two transformations to deal with, an A transformation, a B transformation, okay? In the next video, we'll do the more complicated ones that have all four transformation letters, A, B, C, and D. So, what are we going to do with this? Well, step one, what trig function? You have to decide. I mean, you could do lots of different things here. Me, I see that steer's head. I see that shape of West Virginia, and I say, ooh, that's positive cosine. Now, if I knew this x value, which is actually pi over 4, 0, because I'm averaging those, then I could say, hey, my graph starts here, then I've got a negative sine graph. Or if my graph starts here, I have a negative cosine graph. Or if I start here at 3 pi over 4, 0, this would be positive sine. And if I start here or here, these are positive cosine. So really, it's up to you which one you're going to use. I will say that I'm going to always start with this left point. And this left point is high. I'm going down low and then back up again. So I know that this is going to be cosine x. Okay, so this is a cosine graph for me. Could be something else for you. Could be negative cosine starting here. I'm just going to go with cosine because I'm going to start here. Okay, so then what do we want to find? Well, we want to find our A value and we want to find our B value. Well, remember, our A value is found by taking this number, the D, and adding something to it to get this Y value. Well, I don't see a D here, which means D is 0. So what did I add to 0 to get this? I added 3. And what did I take away from 0 to get this? Ooh, I subtracted 3. So A equals 3. Okay? Today. Yeah, A equals 3. And B, well, remember, in the last video, I said that we would have 2 pi over the period as our B value. And the period is the distance from here to here. What is that distance? Pi minus 0 is pi. So B equals 2 pi, and our period isn't pi minus 0, our period is pi. And so we end up with a B value of 2. Is this a positive cosine or negative cosine? Since we're starting high, this is a positive cosine. Okay, so y equals 3 cosine 2x. That's it. I'm all done. So let's see if we can go through the steps. What trig function? I got to figure out whether this is sine or cosine. Find the amplitude. How do we do that? Well, our amplitude, yeah, I'm reluctant to give you something that's just going to work today that will be not good for tomorrow when we have a d value and an a value. I think what I'm going to say is, since we only have a values today, this number is my amplitude. See, I didn't include the minus. Because my graph didn't start low, go up and back down again. You know, if I had seen pi over 2 positive 3, and here 0 negative 3, that, if I start low, gives me a minus. But since I'm starting high, I got a plus. And so I'm just going to determine A today. B, we're using this nifty formula, 2 pi over the period. Be careful about determining period, you know, from starting x value to ending x value. Period is ending x minus starting x. So my ending x is pi, my starting x is 0. Pi minus 0 is going to be my period. Pi minus 0 is pi. So we had 2 pi over pi, or 2. So I'm going to find an a value, I'm going to find a b value, and I'm going to plug both a and b in to one of these forms. Okay? All right. So let's try another one. How about this one? God, did I really just do that? Sorry, let me take that away. Okay, this is 0, negative 2. This is pi over 3, 2. And this is 2 pi over 3, negative 2. Okay, these are the points I have. What can you tell me? Is it sine? Is it cosine? Is it positive? Is it negative? What do we have here? Well, since we're starting low, going high, and coming back down again, I think this is going to be y equals negative cosine. Good. What's our a value? Yep, a value is 2. And remember, the b value is 2 pi over the period. How do we figure out the period? What's the distance from here to here? 2 pi over 3 minus 0. So our period is 2 pi over 3. Okay, so if I do my flip and multiply thing, that's going to be 2 pi times 3 over 2 pi. Oh, our b value is 3. So I'm going to take this, and I'm going to take this, and I'm going to write y equals 2 cosine 3x. Now, why does that get marked wrong? Yeah, you heard me. This gets marked wrong. Why? This is not the equation for this graph. How come? Cosine starts low, negative. Negative cosine. If this were positive cosine, we'd be starting high, going low, and back up again. That's positive 2 cosine 3x. Yeah, that's not our graph. Our graph is negative 2 cosine 3x. Okay, let's do a couple more of these just to build a little more confidence with them. How about this one? Here we've got 0, pi over 8. Oops, no, 0, 0. And here we've got pi over 8, 1/2. Here we've got pi over 4, 0. And 3 pi over 8, negative 1/2. and pi over 2, 0. Okay, so come up with the equation, please. Nice. Good. Yes, I like it. So, what function? Positive sine. Next, what's my a value? A equals 1/2. And b, remember, 2 pi over the period. And our period is ending x minus starting x. Ending x is where one period ends. Starting x is where one period begins. Well, for us, we're starting at 0. We're ending at pi over 2. That means our period is pi over 2 minus 0, or pi over 2. If I flip and multiply, I'm going to get that b equals 4. So what's my equation here? Well, we've got a positive sign because of the shape. We've got a is 1/2 and b is 4. 1/2 sine 4x. Ta-da! Okay, how about this one? This is 0, negative 4/3. This is 2 4/3. And this is 4, negative 4/3. Will you please write the equation for that graph? So what family is this? Is this sine? Is this cosine? Hopefully by now you recognize this as cosine. Is it positive or negative? That's right. Starts low, so it must be negative cosine. Okay, negative cosine. So negative cosine is what we're working with. Now we need to find our a value. What can you tell me about a? A is 4/3. And b? Well, b is 2 pi over the period. And what's the period? Ending x minus starting x. So I get a b value of pi over 2. Y equals negative 4/3 cosine pi over 2x. So this number, I wonder if it always works that way. Well, see what happens. But I do know that the distance from y equals 0, 4/3, 4/3, and that's why my amplitude is 4/3. Remember, amplitude is always positive. I can shove a negative in front of my function, but this number here is the amplitude. The amplitude is the 4/3. This is informing me of shape. Oh, it's a cosine that's been reflected across the x-axis. The amplitude is 4/3. Gotcha. Okay, one last one. How about this graph? This graph. 0, 0, pi, oops, pi, negative 4, 3 pi, 4, 4 pi, 0. I guess there's a point here at 2 pi, 0. Okay, can you write me the equation for this trig function? Good. That's right. I like negative sine. Negative sine x because we're starting on the midline and going down. That's how we know it's a negative sign. If it were positive sine, it would start on the midline and go up. So negative sine. Our a value, yup, positive 4. And our b value is 2 pi over the period. What's the period here? 4 pi minus 0 is 4 pi. And that reduces to 1/2. So b is 1/2. So y equals negative 4 sine 1/2 x. Smiley face. All right. Well, that's it for today's video. I would encourage you to get ready for a quiz if you haven't had one yet in class about this. Okay. Have a fabulous day, and I look forward to working with you in the next video. Bye, everyone.